Hello class, and welcome to today's algebra lesson, which is about piecewise and step functions. By the end of today's lesson, you will be able to graph piecewise functions and identify their domain and range, and also graph step functions and identify their domain and range. So we're going to start with the piecewise function. A piecewise defined function is a graph that has different rules or different equations for the different intervals or different sections of its domain. So essentially what it is saying is you can break the graph down into different pieces that follow different equations. In this particular example that is shown down below here, there are two different pieces of our piecewise function, one moving to the left and one moving to the right. So the first thing we're going to do is talk about how we can graph those. So in order to graph those, we are going to graph piecewise functions by using tables again. So we're going to have our xy table. The first function says that I've got x plus 3 for the x values that are less than or equal to 4. So I'm going to start my table at 4, and then because we want numbers that are less than or equal to, my next two numbers are going to be 3 and then 2. So because it says less than, I started at 4 and went down. Now that we have our values, I would plug those into the equation for just the top part. So I would say 4 plus 1, which is going to give me an answer of 5. Then I would say 3 plus 1, which is going to give me an answer of 4. Then I would say 2 plus 1, which is going to give me an answer of 3. So now I need to put those points onto the graph. So I would go over to 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5 up, and I would put my first point on my graph. Then I would go to 3 and 4, and then I would go to 2 and 3. So when you are connecting now, you only have an arrow on the end where your points are trending. So I started at 4, and then I went 3, 2, 1. So this graph is only moving and only covering the values that are moving to the left, the ones that are smaller than 4. And because it is a linear function, we want to make sure we have that arrow on the end. Then I move on to my second function, or second part of my function. And once again, I'm going to start with 4. So my first value into this table is going to be 4. Now, because I've got a fraction in this piece, I want numbers that can be divided by my denominator. So I've got 4, and then I'm going to go to 6, and then I'm going to go to 8, because those can all be divided by 2. So I'm now going to plug those values in, and I'm going to say negative 3 halves times 4, which is going to give me negative 6 plus 6, giving me an answer of 0. Then I would plug in 6, and negative 3 halves of 6 is going to give me negative 9. So then my value here is negative 3 when I add the 6. And then I do 8 times negative 3 halves, which is going to give me negative 12, plus 6 is negative 6. When I go to graph this second part, notice this piece of your graph does not have the equal to part. Whichever part does not have the equal to part, so in this case the second part, your first dot when you put it on the graph, so when I go over 1, 2, 3, 4, instead of having a filled in dot, I'm going to leave that as an open dot. Then when I go to the next point, 6 and negative 3, then I'm going to fill it in again. And then I'm going to go over to my next point, which is 8 and negative 6. And once again, I can fill in that dot. Then I'm going to go ahead and connect my points, once again, starting at my first dot and then moving through my second and third dot as I continue that trend, and then adding my arrow back onto the end. So when you are graphing piecewise functions, you're going to have two separate tables, both that start with the same x, but both tables are then going to move in the opposite direction. Our last piece here is to find the domain and range. Remember, your domain is your inputs or your x values, and you can plug in any possible x value. So the domain for these piecewise functions that we are going to be studying are always going to be all real numbers. You can always plug in any x that you need to. It's just a matter of whether the x will get plugged into the first part, in this case the number smaller than or equal to 4, or whether it would get plugged into the second part, the numbers bigger than or equal to, or just bigger than 4. For our range, that's where the graph becomes important. Remember, our range is our y values. So as I'm going along this first line, we're going up, 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 until we hit a top, which is 5. Then I drop down to my next line, and then I'm going down, 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 down. So we do have a peak point of this graph, which means that all of your y values, all of the values going up and down, are going to be less than or equal to 5, because 5 is the highest point that my graph can reach as we are moving. Go ahead and try making the table for just this first equation on your own. So we have our first equation, plugging in 1, 2, and 3 because we want the values that are bigger than 1. That gives us this line in the graph. Now go ahead and make the table and graph the line for the second part of this function. So for this piece on your own. So we plug in our values of this time 1, 0, and -1, and we get this second line on our graph. Now go ahead and identify the domain and range of this particular function. Once again, our domain is all real numbers. I can plug in any value for x, and then my range this time, both lines are trending up, and the smallest point that it gets to is -3. The other part of functions that we are going to be looking at is the step function. This is a particular kind of piecewise defined function, so a specific group that we are breaking it down into that consists of constant pieces. Basically, it means your answers can only be one defined set of values. The particular one that we are going to look at is called the greatest integer function. So this is a type of step function where the answers are the greatest value or the greatest integer less than or equal to x. So even though we're looking for the greatest, it says less than or equal to x, so we are rounding down. We know that we are going to do this rounding when you see the x values in these fancy brackets. And once again, it means all values, since we want less than or equal to, are going to be rounded down. There's a couple different scenarios we're going to end up with in this particular case. The first is if our values all lie inside of those fancy brackets. When you are doing a step function and you are making your table, because once again we graph our piecewise functions by making a table, we cannot just plug in whole numbers. So I can't just go -1, 0, 1, 2, etc. I need to plug in values that are going to allow me to do some rounding. So I'm going to plug in y. I'm going to start with -1. Then I'm going to stick in -0.5. I'm also going to stick in -0.25. So we want a couple decimal values in between -1 and 0. We're going to use a couple of decimal values that are between 0 and 1. And then we are going to have our value of 1. So we need some decimal values in between these values here. I'm actually going to use a few more just so that we can really see the point, and I'm going to add in positive 1.25 and positive 1.5 as well. Now, normally we just have our x and our y's, but because of these brackets, we actually are going to have a third column because this problem involves rounding. Because our value of x minus 4 is on the inside, my next part is just going to be to solve the x minus 4. So to figure out what the inside values are actually going to be. So when I solve those, I have -1 minus 4, which is -5, -0.5 minus 4, which is -4.5, and then -4.25 here, and then we've got -4, and then we've got -3.5, then we've got -3.25, then we've got -3, -2.75, and -5. So as I do all of that subtracting, I get these decimal values. The last column then of this table is going to be to actually do the rounding. So putting that fancy bracket in there to say you are now doing the rounding. As you do the rounding, we want to round down to the nearest whole. So these values that have no decimals stay as whole numbers. Then I look at my decimal part. I want the number that is below -4.5 with no decimals, so that's going to be -5. I want the number that is below -4.25 with no decimals, so that's -5. I want the number that's below -3.5, which is -4, and then -4 again. And as I look at this, the number below -2.75 or below -2.25 is -2. Now, when I put this on the graph, that means at -1, -0.5, and -0.25, so all of these values in here, my answer is going to be -1, 2, 3, 4, 5. So at -1, at -0.5, at -2.5, all of those have an answer of 5. When you are graphing these step functions, this particular greatest integer function, you're always going to have a filled in dot on the left, a flat line, and then an open dot on the right. When I go to my next one, 0 to 0.5 to 0.75, that's going to give me all of the values that are -4. And then I've got for the next one, all of the values that are -3. That only builds 3 steps of my step function, but that is enough for me to keep going and build in the rest of the step function. So in your table, you need enough to initially start filling in to figure out what the actual rounding values are going to be. But once we actually start putting them on the graph, you don't actually have to solve for all of these pieces that I have been adding as I continue to talk here. All of these pieces would be the correct rounding if I added onto my table, but they do not actually need to be added on there. Notice every step, we've got one filled in dot on that particular vertical line and one open dot on that vertical line. So it ends up looking like a staircase, which is why they call it a step function. When you fill in your graph for the step function, you should be going from however far down you can get to however far to the right or to the left, depending on which way your stairs are going, that we can fit. I'm going to do one more example of these ones with you together. This is where we have our value on the outside. So it could be in any of these step functions, adding, subtracting, multiplying, or dividing. This first one, so I happen to have subtracting, and it was on the inside. This next one has multiplication, and it's on the outside. So when you are building a table and that factor is on the outside, once again, because it's a step function, I need to make a bigger table. So I'm going to start again with -1, throwing in a couple of those decimals, so -0.5, -0.25, then I get to 0, and then I do my decimals of 0.5 and 0.75, then I'm up to 1, and I'm going to go with 1.25 and 1.5. So then I'm going to go ahead and do the interior piece first. So in this case, it's asking you to do the rounding first because the rounding is what is technically inside the parentheses. So that means what I need to do is round to the biggest number below my integer. So once again, my integers themselves stay the same. The number below negative 0.5 is going to be negative 1. The number below negative 0.25 is going to be negative 1. The number below 0.5 is 0. The number below 0.75 is 0. The number below 1.25 is 1. And the number below 1.5 is also 1. So in this case, we did our rounding piece first, and then the last piece of this table would be the negative, and then multiplying by our rounded values. So when I do this one, I've got negative 3 times negative 1, which is positive 3. Negative 3 times negative 1, which is positive 3. Negative 3 times negative 1, which is positive 3. Negative 3 times 0 is 0, 0, and 0. And then negative 3 times 1 is negative 3, and negative 3. Once again, then, we take our values and we are filling them in. So from negative 1 to 0, I'm going to have a value of 1, 2, 3. My next step then is to go to 0 and 0. And that is my next step in my function. And then I go over to 1 and I go down to 1, 2, 3. Now notice this time there's a gap in our stairs. So when I go ahead and fill these in, I'm going to go down again 1, 2, 3 to put in my next set of stairs. And then once again 1, 2, 3 down to put in my next set of stairs. I can't just go down one space and fill in a set of stairs, so that's all the farther I can go as I'm going down. On the opposite side, I would go up 1, 2, 3 spaces and put in another step. Up 1, 2, 3 spaces and put in another step. And again, that's all the higher you can go. So when we have this multiplication, your stairs are going to get stretched out a little further than they were before. The piece now that we need to look at with either of these functions is our domain and range. Once again, our domain for these piecewise functions is going to be all real numbers. I can plug in any value in for the x spot. Fractions, decimals, square roots, whatever it is, you can plug in that value for x. The second part here is we have, as I look at my steps, I have all of the values here, which would be at negative 10, negative 9, negative 8, negative 7, negative 6, negative 5. So all of those values are all integers because there are no fractions or decimals included in the final answers of our steps. When I come to this next function, once again, our domain is going to be all real numbers because you can plug in any value for x. My range this time, the steps get bigger. I go from 9 to 6 to 3 to 0 to negative 3 to negative 6 to negative 9. So we have those bigger jumps of our steps. In order to indicate that, we would say all integers. So we're still talking about values that have no decimals, but then we would say multiples. So talking about multiplication of 3, because every time we jump, we're jumping 3 spaces. If it had been multiplying by negative 7, every time you jump, it would have been 7 spaces, and you would have said all integers multiples of 7. So whatever your number is in your equation, that's going to help you figure out what your value is as you are doing your multiples. Go ahead and make the table for this one and the graph on your own. So we fill in our table. We do our rounding first in this problem because there is nothing else inside the parentheses, or those special parentheses, excuse me. And then we do our adding afterwards. So we add our values on and get 0, 1, and 2, filling in that whole graph. Now I want you to go through and name the domain and range of this particular function. Once again, your domain is all real numbers and your range is going to be all of the integers. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.